Hello students, in previous video we discussed about key management. Now in this video let's see about key storage. So secret keys needs to be protected from exposure to parties other than intended owners because we need to provide the security. For providing the security we are using the secret keys, and those secret keys also you have to prevent from the others to access here. So that's why here caution is how to store the keys to prevent from exposing of the keys other than those two parties. For storing the keys there are two types are there. One is you can store the key in software or you can store the key in hardware. First let's see key storage in software. Storing keys in the clear. So here in the clear means whatever the key you are having, no, that key you are storing in the software. Okay, while building the softwares, while implementing the softwares, while developing the softwares, so these keys are you are storing. So then the developer is also know that where that key is stored in a software here. So then that is the problem. So in storing the keys in the software here as it is. Clear means what it is, that key you are storing as it is. Next one is storing keys using cryptography. Cryptography as instead of storing that key as it is, you are converting that key, okay, and that converted version, that one we call as a cipher key, and that cipher key you are storing in a software here. So for that procedure what we call software storing keys using cryptography. One way is encrypt it with yet another key. So which key want to store in a software node, that key first you have to encrypt as a cipher key and you store, okay, in a software. So then one second caution is what, for encryption also you require the one more key. Then where you will store that key? So then once again you have to repeat the same procedure. So that is the one problem here. Next is generate it on the fly, dynamic here. So now while developing the software, so wherever you require you run, okay, dynamically you create a key and you store it that. So there it is what it is, you require the procedure to generate the key dynamically. Next is store it in a hardware. So now instead of storing that key in the software, in the hardware place, in hardware device you can store that particular key. So here you are storing in the hardware device, that key is not in the, okay, clear key here, okay. So that is encrypted here, or it may be converted into another form because here you are using the cryptographic graph. So now you can store it in a component form. So in the hardware you are having the different components now. So in the same way key is also considered as a one component, and that component you can, okay, store, or as a key you can store in the form of the component in a hardware devices here. So this is key storage in software. Either you can store while developing the key, okay, software, you developer will store that key as it is, the developer will know that is the risk here, or you can develop the, okay, use the cryptographic terms, that is instead of storing that key as it is, you convert it into another form. One is either you can encrypt or you can use the, okay, dynamic key generation procedure, okay, key generating procedure you have to use, or you can store that converted form key in a hardware or one of the component form here. Next one is the key storage in hardware. So for storing keys in a hardware security modules are available. That one we call as a HSM. So these are the modules used for which purpose? To store the keys securely. So here problem arises is what, if you are using the hardware security models, then you have to prevent from the tamper resistant devices. Okay, if it is device itself, if it is tamper, then you can't get your key here. So then what are the device you have developed? No, that device must be tamper resistant device here. There are various techniques that can be used to provide the tamper resistance here. So that how we will provide this module, okay, hardware security models from tamper resistant. So these are the various techniques are there. One is micro switches. Micro switches means what, you are having, okay, switches in that HCM. So whenever anyone try to tamper that device, then automatically switch must be off here. So that is what we call as a micro switches here. Or electronic mesh. Electronic mesh means what, it, covers that particular old model, and it provides as a one security layer for that module. Anyone, if they try to tamper that while touching that, so it give the electronic mesh, that give the electronic shocks here. Or resin okay. So resin, this one is also the same as the electronic mesh. So here, instead of providing the security layer for the old model, which model, okay, in the model you are having the several components now, which component is sensitive, so for that you are providing the electronic measure, okay, measure, because it is costlier here. So then you can go for the tamper resistance with the help of the resin here. Temperature detectors. Temperature detectors means what? Variation in the temperature here. So now if there is the variation in the module temperature, then indicates what? Someone is trying to tamper that particular device here. Or light sensitive diodes. So light sensitive diodes are sensors we are using. So now if anyone try to, okay, tamper or touch that particular device, so this light sensor diodes will give the, okay, sensor, okay, alarm here. So from that alarm you will get alert that as someone is trying to tamper your hardware device, because it is a hardware device now. So that's why tamper resistance is very important here. Or movement or tilt detectors. Movement or tilt detectors, once again sensors you are using. If anyone try to, okay, move that, or if they want to try to tilt that particular device, so this sensors will, okay, sense it and it gives the alarm or as a message to the owner here. Or voltage or current detectors here. Variation in the voltage here, okay, sensors you are using to detect the variation in the current and the voltage. If it is varied, then sensor will sense it and it gives the alarm here. Or microprocessor chips, that is the security chips here. You are using the microprocessor chips to provide the security for the HSM here, okay. So hardware security models are hardware devices. So yes, you can use this for storing your keys in a hardware device. Then there is the chances of anyone can, okay, tamper that device itself. If they are not able to get the key, so then what is the thing? They will tamper it, okay. So then what is the procedure you have to do? You have to prevent that device from the tamper, okay. So that is what you call as a tamper resistance, and these are the several techniques which are available for tamper resistance proof. So key storage on HCHSM. HSM is what it is? Is hardware storage, hardware security modules here. There is a least one key, okay. So now how many keys you can store in this HSM, okay, hardware security model, that is the device, hardware device, it is developed to store the keys. So then question is how many keys, because you already learned about key hierarchies. So in the key hierarchies you know that you are having the several keys, okay. So one is your master key, that one you are referred here as a local master key here, and that one at least you can store in the, okay, HSM, that resides inside the HSM at all times, okay. So in the key hierarchies, okay, local master key is required, and with the help of that key you will get the encryption keys, and with the help of those encryption keys you will get the session keys here. So now main key is the master key, so that's why you can store this master key inside the HSM at all times, okay. So one more way is there. Here question is, so whether you want to store the keys inside the HSM or outside the HSM and encrypted using an LMK here, okay. So now inside the store, inside the HSM means what it is, while okay, building that particular model, so you can take as a component, and that component contains the key, and you will build the thing. So that is what we call as a store inside the HSM. Store outside the HSM means what it is, you are encrypting the key with the help of this LMK, okay. So local master key, and with the help of this local master key you will encrypt, and after encrypting that key you are storing outside the HSM here, okay. So here in the outside HSM means what it is, you are using the encryption key here, you are encrypting that key and you are storing that one. So either you can store inside as a component, or you can store the encrypted key using with the help of the LMK. So this LMK you need to provide the security. For providing that, always this local master key must reside inside the HSM here. Okay. So this HSM, if you want to get, so you will get from the HSM device here. So if anyone tamper this device, then you are not able to get that particular local master key here. If you don't know, if you have lost this local master key, okay, then also you are not able to use that particular key here. Why? Caution is because your encrypted key is stored in the HSM. So to decrypt that key, you require the local master key, and that local master key, if you are lost, then it is not able to get or decrypt that key here. Okay, so that's why here LMK is very important if you are using store outside the HSM here. And store inside the HSM, tamper resistant is very important. Okay, if anyone tampers and if they try to get the key, then it's the thing here. You may have the question, which one is good? Either we go for storing the key inside the HSM or outside the HSM here. Yes, according to efficiency, it is more efficient. Performance of that one is efficient if you store inside the HSM here. As I told here, it is fast here because you are storing the. Whereas in the outside the HSM, first you have to get this LMK, and with the help of that LMK, you have to encrypt the keys, and after encrypting, you can store in the HSM here. Okay, so this comparatively both are good. It provides the high level security, and this one, if it is tamper resistance is not there, then it's become the problem here. But efficiency, if you compare, store inside the HSM efficiency is good here. Okay. Next is the risk factors of key storage. If you want to go for key storage in hardware or software, you have to go for risk factors, and based on the risk factor, you have to decide whether you want to store with the help of the softwares or in hardwares. In hardware also, whether you want to store inside the HSM as a hardware security models or outside the hardware security models here. That is depends on your risk factors. Risk factors depends on environment and device. So in the environments, you are having the different types uncontrolled. You can't control. If you go for the shopping, okay, in the shopping also you are using the, okay, devices. So there everyone have the authority to access here. So in that situation, providing the security is uncontrollable. Okay, so that situation you call as uncontrolled. Partially controlled. Partially controlled, if I take our office or college devices or your personal PCs. Okay, so those are partially controlled. As you can control with the help of one security password here. With the help of the security password, you can provide the security who know that security key, and they can have the authority to access here. Whereas in uncontrolled, everyone can access here. In the shopping mall, if you want to go for the window shopping, everyone has the authority to browse that window shopping. Okay, because they are not necessary to access security key to access the things. Whereas in partially controlled, it's maybe the any home system or the office system here, then you require partial control. Okay, next is the controlled high level security, confidential data. If you require, if you go for the say military security, okay, in the military and in any confidential data, if you are required in hospital management and in the military system, so there you require the high level security, and for accessing that you require the high securities here. So such type of the environments you call as a controlled base. These are the three factors, risk factors based on the environments. One is uncontrolled, partially controlled, and controlled. So you check the environments, and based on that you provide the security here while storing the keys. So partially keys, as I told, you can just enough with the help of the password key. If it is controlled, then you have to require the HSM models, and for those HSM models also you require to provide the tamper resistance, all those things. Devices. So yes, this is the situation. Environments are controlled, uncontrolled, partially controlled, and uncontrolled here. So in the device also you are having the different types of the devices. General purpose devices. Dedicated devices, specialized devices. General purpose devices means what? Any system. If I take the any of the desktop system or the laptops, there also you require the security. As you already know that if you want to use the any of the particular laptop, then you require the password here. Once if you know that password, with the help of that anyone can access. So if you go for the any system, for that system also built-in securities are available in the system and the PC, that is laptops, and those itself is enough to provide the security here. Dedicated. If I take your mobiles, so in the mobile everyone will keep the pattern compulsory here. Why? Because it is dedicated or personal to that particular person here. So such type of the devices we call as a dedicated. General purpose means what it is, those systems anyone can use here. So built-in securities are enough to provide the security. If I take the dedicated, it is personal for your own purpose if you are using. So like your mobiles, then you have to use the security that is known by that particular person only. Specialized. Specialized devices are like your HSM model, hardware devices you require to provide the security here. Okay, so built-in securities are not workable here. You require the extra high-level securities. So such type of the devices we call as a specialized. In specialized, you are taking the help of the HSM and all those things here. So this is the risk factors based on the devices here. And also you know the risk factors based on the zones. This is zone 1, zone 2, zone 3 and zone 4. Zone 1. So as you know that here it comes uncontrolled and partially controlled, general purpose and dedicated devices. Environments are controlled and partially controlled. So in this zone, okay, you require the low level security. That security may be the password or the PIN. With the help of that you can provide the security. That much is enough here. So controlled, okay, in the controlled you are, okay, once again it comes the general purpose and dedicated devices here. As along with the PIN you require the some built-in functions to provide the security. So that comes under in this control. For example, if you go for the any of the system, if you want to access the internet is the open source network. So to provide that one you require the built-in functions to provide the security here. So that is what we call as a controlled here. Next is the specialized. As I told, it is hardware device. So here also risk factor is high. Okay, so I require the high level security. For the zone 3, I'll take the example of your ATM machine. As you know that here you are having the specialized device, it is hardware security model, it is there. That model itself, if anyone takes and afterwards they will try to access the what are the keys are there in that particular model here. So that is, it is specialized device here. So there you require the security to prevent from stole, okay, or to get that model here. Next one is the not possible to access that device itself. It is specialized. Here also you are using the HSM. So even if anyone try to touch that particular model, it gives the tamper resistance proof here. Okay. So in the specialized you are using the tamper resistance here, whereas here you don't have the tamper resistance. Physical security you have to provide for specialized devices like your ATM here. Okay. So whereas in the zone 4 is hardware devices are required to provide the security as HSM. So now for that also you require the tamper resistance here. Okay, high level security you require. So these are based on this risk factor, you have to go for the key storage here. Okay, thank you.